Welcome. So we're now going to talk about what happens when your A value is between 0 and 1. So think, what does it mean to be between 0 and 1? It means like you're a half or you're a quarter, but you're not greater than 1 and you're not less than 0. That's kind of what you've got to think about in your head. So over here, my A value is a half, so it's between 0 and 1. Now, what we're going to do is we're going to fill out the table of values, and then we're going to plot it, and we're just going to see what on earth is happening here. Okay, so let's begin by letting x be equal to negative 2. So if I let x be equal to negative 2, and I might do this in a different color, let's do it in orange. If I let x be equal to negative 2, what happens? All right, so I'm going to end up with y is equal to a half negative 2. Now remember, when you've got a negative power, you take the reciprocal of the number. So what's the reciprocal of a half? It's 2. And now you can change the sign of your exponent. So this will be 4. And then what's going to happen here? We're going to get this. Oh, my 2's are looking especially ugly today. Negative 1. Again, when you've got a negative exponent, you take the reciprocal. That now becomes positive. Y is equal to 2. When anything is equal to when anything is raised to the power of 0, you're always going to get 1 out. No surprises there. But then what's going to happen here? What's going to happen when I've got a half raised to the 1? Well, it's just going to be a half. No surprises. What happens when I let my x be equal to 2? Now, this one's an interesting one. Well, would you agree that what's going to end up happening is you're going to get 1 squared over 2 squared, which means you're going to get 1 on 4. 1 on 4. Hopefully you can see what's kind of happening here is it's the reverse of what we saw before. So here it's 4, 2, 1, 1 half, 1 quarter. This is a half raised to the x. Before, we were dealing with something like this. So 2 to the x. Do you see how it's a quarter, a half, 1, 2, 4? The order has swapped around for this one. That's interesting. Well, let's now plot this onto our graph and see what it looks like. Okay, so when I let x be equal to negative 2, I'm going to get a 4 out. It's going to be there. When I let x be equal to negative 1, I get 2 out. When I let x be equal to 0, I get 1 out. When I let x be equal to 1, I get a half out. When I let x be equal to 2, I get a quarter out. Do you see what's happening? Now, this is where I'm going to butcher it. I'm going to try to draw it in. Ready? Okay, that's pretty shaky, but okay. So as you can see, what's happened is I've had a reflection take place. I still have the same y-intercept. I still have an asymptote occurring at y is equal to 0. But do you see how it's flipped from what we've previously seen? This here is y is equal to a half x. And you notice how this is the opposite way around to what we previously saw. Previously, we saw something that looked like this. This was y is equal to 2x. So as you can see, what's happened is that we've had a reflection take place. And we can draw this on our CAS as well. Let's come here. I've already got 2 to the x in here. Let's put in. Perfect. Look at that. We have a reflection. All right. So how is this a reflection? What does this mean? All right. Let's scroll down here. Let's have a look. It says what? Oh, that's not a highlighter. Let me try that again. What transformation has occurred? The graph y is equal to a half of x is obtained from the graph of y is equal to 2 of x by a, now this is the part that you should highlight, a reflection in the y-axis. We have reflected it in the y-axis here, not in the x-axis, in the y-axis. We've reflected it across that line there. And what do you know about this? Like, we've seen transformations before. We know that a reflection occurs in the y-axis when we have a negative in front of our x value. Well, guess what? If we have a half, if we take the reciprocal of that, it becomes 2 to the negative 1, and then we can just distribute that out. Do you see how we get 2 raised to the negative x? So this makes perfect sense as to why we're getting a reflection in the y-axis. And you can have a look at this here. This is what it looks like. So notice that you're still getting an asymptote at y is equal to 0. You're still getting the same y-intercept. But when when a is less than 1 but greater than 0, you're going to get that reflection taking place. All right, let's just talk about some properties before we finish up on this part. Let me grab my highlighter out. So it says, in general, the exponential function with the rule this, where a is between 0 and 1, and its graphs have the following properties. The x-axis is the asymptote. So the x-axis is the asymptote. As the x values increases, the graph approaches the x-axis from above. So as x increases, my y approaches 0 from above. So look at your orange graph here. As you can see, as my x values increase, my y values approach 0 from the positive side. The y-axis is still 0, 1, the y-axis intercept, and the range is still all positive real values. Okay, so that's what a reflection in the y-axis looks like. It occurs when your base is between 0 and 1. Hopefully this made sense. I'll see you in the next part.